Welcome to another Pixel Game Maker tutorial. Today's other runtime action we're going to go over is the change switch variable. Now while this may sound like just a basic turn on and off a switch or change variable value, there are some interesting things to consider, some ins and outs of using this runtime. So with that, let's get started. And with the runtime selected, let's get into the two options, which are change switch and change variable. Now what you'll notice is that the first three boxes for both variable and switch change are the same. And that is because these are the areas where we are going to select what object do we want, maybe specify it, and then select the switch, or in variable's case, the variable. So let's go over some of these options. In this first drop down box here, we select what switch do we want this object to be coming from, or object instance. For instance, the object self is going to be referring to not only the object, but also the instance. And what I mean by that is, let me select this object self and hit OK. And we'll go to the scene here where you see that I have two instances of this same object. All right, the beetles. You see I have one object beetles, but I have put it on the scene twice. So therefore I have two instances of the beetle. So when we are using, let me go back to this check here. In this example, object self won't really do us any good if we were targeting the beetle because we are running it in the player object. So when we're referring to the object self, we're actually referring to this object's self switches. So if we were to go into the beetle's object and say that when we destroy, we also run a switch, we could say run this object self, and then we could select a switch and hit OK. And we could put it above destroy because if it was like this, it would destroy before it changed that switch. And then in the scene, these beetles would actually be referencing to its own switch. So when I destroyed this beetle, that switch would only turn on for this object. If I destroyed this beetle, that switch would only turn on for this object. Now that's not a very practical example because you wouldn't really turn on a switch for this object right before it dies, but I just want to show you how the switches would go for that. All right, so now if we go back here, and before we move on with the switch types, let's actually show you where to find these switches, where to find the object self switches. And in every object, there is a variable management and a switch management tab. And you'll see that there are some green colored switches and green colored variables. So these are the object self switch variables that are being referred to, and they come with every object. All right, so now we can move on to the project name common folder. So I say project name because this name is going to be the title of your project, and then it's going to have common always. So I always just refer to them as your common switch variables. So if we were to select that, we would then have a list of our common variables or switches that we have in this case. And if I was to click OK, you find your common switches in the resource tab under switches. And this is where you'll have all of your switches. By the way, you can easily see where your switches are and move to them very easily by clicking on them, right clicking and then clicking on move. And there's also one for variable. And there's some green ones, which are the default ones that come with every game. But that is how you would get a hold of a common switch, for instance. Now, a common variable would help us in this instance because we could turn a common variable on in this attack, and we could have a condition for these beetles to react to a common switch, and it would work because it's kind of a global thing and all objects will be able to detect it when it turns on, where the object self option is just talking about this instance. And you can see that some of these boxes won't be able to be chosen, and that's because commons are for everybody. You can see that on the object self, you can see that we also couldn't choose any other option right here, and that's because it's only referring to the instance. And then this box down here with common selected, I can grab any switch that I want. So now let's go to the next one, which is going to be a lock object. Now the locked object is going to be detecting switches, or sorry, it's going to be changing switches from a locked object. Now, if there's no object locked, then this runtime won't do anything. It'll just skip. So just note that an object must be locked in order to change that switch. Now, it's very interesting because you'll click on locked object, but then how do you know what switch you're looking for? Well, in that case, you just select any switch as long as the object has that name. For instance, the Beetle. There's one called dead here. So if I had this one on dead, the object that is locked would have to have a switch called dead in order to turn it on. And so say I had another object that had a dead switch as well, it wouldn't matter where I selected that dead from. For instance, just for example, I could take the Beetle, I could duplicate it, and I could just make this a new one called enemy 2. And then in the player here, under that runtime action, I could go to enemy 2 and I could select its dead switch. And what I'm trying to mean here is that it doesn't matter right here which one you select. All that matters is that the locked object, when this is run, will be detecting for a name called dead. So if I wanted to add this switch to any object, all I would have to do is create a self switch called dead, and then this locked object option would work. And that goes the same for the parent. When you're selecting, it doesn't matter where you're selecting, it only wants the name of the switch. I hope that makes sense. All right, so now there is other options on what to do, and this one is you can actually select the object specifically. So in this case, we can select the Beatles specifically. And when we select that, we get an option in this drop-down menu of single or all. So let's start with single and see what that does. Now just real quick to show you, in the Beatles condition to the die sequence, I have an OR and I have if the self switch dead is on. All right, so this is under the Beatles. So if the Beatles self switch dead is on, then it will also be destroyed. All right, and I'll go over these conditions in other videos. Just wanted to point that out. So now when we attack, it's going to turn this dead switch on and it should kill the single Beetle. So when I attacked, it killed the single. Now, why was this one the single? So let's take a look in our scene tab here. When you are putting on your objects, say you put on multiple objects, which I have, with 2 Beetles here, you'll see right up here, right under display priority, it has a single target, and this one is checked. And then if I click on this one, you'll see that single target right here. This one is not checked. So the single is referring to the one target on the scene. So only one object of this type, or instance of this object, I should say, can have single selected per scene. And that just gives you some quick options. It's not a catch-all for changing switches all the time. It's just a easy option. Say you only have like one scene manager or 2 scene managers. Let's just say one for the boss's health and one for the boss's phases. Well, you could designate one as the single, and then it would just be really quick to set up in your logic. Otherwise, there is a method to actually select the individual one that you want, and we'll get into that here in a minute. But so this one has single selected, so let's just say I clicked single on this one now. If I click on this one, you see it unchecked, and now if I was to hit play and attack, it now hits this one because this was the single that I turned on. All right, so the next option would be to select all and see what happens when we select all. It's pretty self-explanatory, but if we were to select all and press playtest and attack, we would see that it turns all of those objects self-switch on. Well, what if we have, say, another object here? I'll just add another one, and we'll call this one Beetle 3. And let's say that I just wanted to specify which one it was and not have it based off single or all. Well, then we could actually use this option right here. This little, it looks like a camera, a film camera icon. You would turn it on, it'd turn white, and this is called changeable even after placement on scene. And so what this allows us to do is go into the scene, and you have to click on the object that is changing this switch, which is the player in our case, and then it would pop up right here. So you could see that in our attack state, because that's the attack box that we're in our attack action, we can now come to the switch here and we can drop this down, and now we get a list of all of these objects on the scene. So now we could select from the specific Beetle 3, and it should be this top one right here if we were to play test and attack. And there we go. So that's how you can specify what instance of that object if you need a specific one. Now do note this also still has some limitations. For instance, if you're generating objects, then there's no way to actually select them on the scene like this. And so generated objects, bullets, say you're changing an object, these could all be situations where you couldn't use this. So just keep that in mind and you should be good. All right, so I'm going to turn this off for now, and then we can go to the values. Then when you click the drop down menu, you'll see that we have three options that we can change this value of this switch. And the first one is on, the one that we've been using. So we've been turning it on and then they destroy. You could also change it to off. Now in programming senses, these are true or false, and so they don't really need much explanation. I will briefly mention this third option called toggle. And what this is going to do is it's going to flip the value to be the opposite. So if you if this switch was already on, say on, and then in this change switch we toggle it, it's going to take that switch and flip its value, so it would turn it to off. And then the vice versa, if you had it already off and you toggled it, it would turn it on. Now this has some very limited uses in my experience. I actually don't use toggle too much just because I like to have more flexibility in my action logic. So I like to pull things out of actions, and toggle doesn't really play nice if you're doing stuff like that. So if you're using a lot of execute object action or common actions, I wouldn't use toggle. I would very hard code these things true or false, or sorry, on and off. But there is that option. So if you have a very linear object that can only do certain things and it's just going back, what is nice about toggle is that you can just click it on. So you can just click it and have it there. And then you can just copy paste it in the other action that you want to toggle it again. And so you don't have to go back in here and go here and say off. So I'm not going to say toggle doesn't have its uses, because it definitely can make your workflow a lot quicker. So that's how that works. And that's pretty much it for changing a switch. So now we can come down here to change a variable. Now these first three boxes, like I said, are exactly the same setup. They just have different variables you can pick from. So if we were to go to the object self, we could then choose from all of these variables. If we went to the common, we could choose from all the common variables, and so on and so on. One thing I don't think I mentioned too much in the switch is that this parent object here, that is referring to the parent of this object that's calling. So this object could be a child in all cases, and could be connected to the child or generated as a child, or the bullet could be a child even. So you could be changing the parent, which in the bullet's case would probably be the player. So it's some ways that you can, for instance, if the child bullet is moving and hits an enemy, you can then turn on the player's switch that an enemy was hit, for instance, and have a specific result from that. And so in our case, we have the Beatles, right? And we've already learned about this in changeable even after placement. So I'm just going to say all. And we have a bunch of preset variables that come with every object. And some very important ones are obviously the HP. And so I'm going to set them equal to 0. All right, so that's what this operator in this drop-down menu means. And we'll go over all these. I just want to show a quick example of selecting a variable, for instance. And then the default is set to be a constant, and the default value is 0. So we're going to hit OK. And I will show you in the Beatles, that is one of the first checks, is to check if the HP is 0. And if we were to play test, and if I was to attack, they would all turn to 0 HP, which would then trigger the death sequence. All right, so now we can go over the operators here. If we click on this drop box, we can see that we have been using this equal. So we're saying that when we're changing this HP variable, we're equaling it to this constant, which is 0. Now, if we were going to click on this plus equal, this would be add. Okay, so we're going to add 0 to the HP, which does nothing in our case, but that's what that operator is saying. The next one is the minus equal, and that's saying that we're going to minus 0 from HP. So if you're looking at how to read this, you can go to it like this. You can go to the operator first. So I'm going to minus 0 from HP, and that might help you. So then the next thing we have is the asterisk equals, which is the times multiplier. So we're going to multiply 0 with HP. Now in this case, the death sequence would trigger, because obviously adding 0 and minusing 0 is not going to do anything to make the Beatles HP 0. But if we were to times the HP by 0 and we play tested, then that would be true and they would all die. All right, so the next one is the divide sign. So if we were going to divide by 0 the HP, I can't remember what that actually does. Let's go. Let's play test this. Okay, so what that did is, let's check. We can go to the debug menu. So if you hit F1, debug menu, object data, you can pull it out here, and we can go to, say, Beetle 1, and we can go down here to see the deaths, or it was HP. All right, so this actually is a good thing to go over. So there's a NaN, not a number. All right, so that's the value. Okay, now in the condition check here for, well, let's change this one. Instead of using this HP as 0, we're going to go to actually use the Beatles, and we're going to say HP equals, and we can say non-numeric. All right, non-numeric. If we click on the non-numeric, that's the value we're checking, and we attack, they all die. So I'm glad this kind of happened, because we can see that there is a check for the NaN, or not a number, and that is the check for it. All right, so that would be dividing it by 0. I mean, which isn't really practical, but there is. And then we have this percentage sign equal to, and that is the modulus, is what it's been referred to. And this isn't really a good example to see modulus. So what I'm going to do is I'm going to exit this tutorial. I'll save it first, and we'll exit this tutorial. And we're going to go to the ladder sample, which is where modulus is used pretty well. And we're going to go to this state in particular. It's the checking for if, or after the check to see if you can climb the ladder, this is how it puts you on the ladder, all right? And you'll see that it has a bunch of variable changes here. And one of them is modulus by 10,000. All right, and what modulus is doing is it's checking for the absolute value. And so for in this ladder sample instance, what it's trying to do is it's dividing the x of the player, because right here it has an x keep variable, so it created a variable called x keep, and it's of the player's x coordinate. Then it's dividing the x coordinate by 16, which is the tile size, so 16 by 16, so that's what they divide by. Then they're trying to check the absolute value. Now, in this sense, why the number 10,000? I was kind of curious too. It doesn't matter so much 10,000. It just is. It needs to see if that number can go that high. And so let me show you why they did 10,000. They actually only needed to do 100, I believe. So if they did 100, and if we were to play test this, let's see here. Oh yeah, it's of this. So let's go to our object here, and we're gonna put in this actual player one right here. All right. So now if we play test this, and then if we go up here, yeah, okay. So they only needed 100. And what it's the reason why they had this number right here is because they need to know how many dots count is for that scene. And what they need right here, for instance, so right here is the dot count. So they're looking for the X dot count, which is this first number. Right now it's negative 88. So you can see it going up. So you can see when I get to this first ladder, the dot count is only 71. So we actually only need to be the modulus constant that we're checking, we only need it to be 10. So we can see that if we were to change this to 10, and I hope this isn't too boring. I actually thought it was kind of interesting. So if we change the modulus to 10, we can go up this ladder perfectly fine and the logic will work fine. If we try to go up this ladder, it's going to send it back because we're not checking for enough zeros. We're not absoluting it by enough zeros. So if we were to go to this scene and we take our cursor and go over to this ladder, we'll see that the dot value is 184. So we need at least 100 to be that value. The same is for this ladder, it's 296. So we need at least 100 because there's 3 digits, so we need at least 100, those 2 extra zeros, to be calculating this. So then if we were to go way out here, say our scene was multiple scenes, this 1000, now we would need 1000 as that value in order to be detecting that grid. All right. And because that's what it's doing is it's finding the actual grid place that it's at. So it did 10,000 just for because you're never going to have a scene that big, 10,000 dots. So, and if you do, you just add another zero. But anyway, so that's what it's doing. Then after it finds the absolute value, so it knows what grid you're in, then it retimes it by 16, adds 8, which is a half tile, and then it makes your position onto the ladder in the center. And that's how you get that snap effect in this ladder sample. And so if you're ever curious about how to run an equation, this is a perfect sample to look at to see how it does, because we can see that it runs from the top to the bottom a list of equations that it's doing, and then the final result is right here. So this would be the only reason we're actually running this, but to get there, we had to do this many different things to actually get the correct value. All right, so while we're here, let's go over this next option of setting the value with another variable. We've been doing it with constants, but they did it in this case with a variable. And this is a fairly common practice to have a temporary variable that is storing the value of a variable, like for instance, x coordinate position, which is updating constantly. So they took the time and place that the x coordinate was in, they stuffed it in a temporary variable, and they did it by using the variable option. You have these options right here: self, common, locked, or parent, and then you can select the variable that's values, in this case, will equal, so the x keep will equal the x coordinate position. So that was the first thing that they did. And the only other thing to go over is that we can also have a random value associated to this variable. So instead of equaling it to the x coordinate, for instance, we could say we want this value to be from 0 to 100, and it would throw a random number from 0 to 100, and then you could use that as, for instance, random generators or random item drops. It's one method for doing that. The last thing is you can also do a script. I'm not going to get into script calls. I'll save a tutorial for just specifically script calls, and then I'll go into all of these ones that you can add script calls to and stuff like that. But mainly just want to show you this. And for instance, let's just do this random 1 to 100, and I'll just show you how this works. I'll hit OK here. So now the xkeep is going to roll a random number 1 to 100. I'm going to skip all of these so that we do not run this equation. And then if we go to play test here, when I try to go up a ladder, it will have ran that number. So if we go to player and we go to the xkeep, you can see that it randomized 14. If I was to reset and try to go up again, you can see that it rolled 84. So that's the value there, how it's randomizing. So that is it for this video on how to use change switch and change variable. A little longer, but there was a lot of little details to go over, and I know there is usually some questions associated with this, so hopefully it was clear enough. Any questions, drop comments down below. We'll get them answered. Visit the Discord. Helpers will get you all figured out, or the forums will get you in the know. And with that, I'll see you at the next video.